You know that chart everybody screenshots to argue about which AI models people actually use? Open ones versus closed, Chinese labs versus American?
OpenRouter's rankings. It's the closest thing the industry has to a public scoreboard.
Stripe just agreed to buy the company that runs it.
The payments company.
The payments company, announced this morning.
Okay, so the toll booth just bought the intersection everyone drives through. That's the whole day right there.
And it's genuinely the biggest story, so let's start there. So start with what OpenRouter even is, because most people only know the rankings.
The switchboard. Instead of writing a separate integration for every lab, Anthropic, OpenAI, Google, DeepSeek, dozens of smaller hosts, you point at one endpoint. OpenRouter picks the model and picks who serves it. It routes across more than 400 models from over 80 providers.
And because it's the thing in the middle metering every call for billing, it can count them.
Right, it counts the tokens and then it publishes the count. That's the accidental part. A convenience layer became the only public picture of what developers actually run, as opposed to what benchmarks well.
Which is why it matters more than a normal infrastructure deal. When we said Chinese models passed American ones in real usage back in June, that number came from OpenRouter's own data.
The real story is underneath. Stripe was already inside OpenRouter's stack. Since January, Stripe was the billing rail underneath it. Invoicing, tax, fraud. This isn't a payments company discovering AI. It's a payments company absorbing a router it already sat beneath.
The toll operator buying the interchange it was already collecting tolls at, it owns the meter and now the decision about which road your traffic takes.
And that decision got more interesting recently, because OpenRouter rebuilt its automatic router around aggregate spending, what the whole platform is paying for. So whoever owns that signal owns a real nudge on which labs get traffic.
Let me push on the worry though, because I think there's an honest counter. Routers aren't load-bearing for everyone. OpenRouter's own engineers admit the extra hop costs latency and money.
True. If you run one model at steady volume, going direct is simpler and cheaper. The router earns its keep when you're switching models, hedging against an outage, or chasing price. Otherwise, it's overhead.
What I keep landing on is the asymmetry in the promises. OpenRouter said the mission, the name, the product, the roadmap all stay the same. Stripe's announcement doesn't mention the rankings at all.
Party being bought made the commitment. The buyer didn't repeat it. And nothing's actually closed yet. This is agreed, not done, closing expected in the coming weeks.
One thing to clear up, because it's all over Reddit, the $7 to $8 billion price tag. Neither company said that.
Neither primary announcement names a number. That range is press reporting, so treat it as rumor until a filing says otherwise. The thing actually worth watching is whether that public scoreboard stays public once the company owning the payment rail also owns the switchboard.
Next one is a small mismatch that turns out to matter a lot if you benchmark models. DeepSeek's API is serving a version it calls v4 Pro-0813, a dated stamp,
and the weights you can download from them carry no date at all. It's just v4 Pro, no matching 0813 page anywhere.
So the model you download and the model the API serves, you can't prove they're the same thing.
From DeepSeek's own materials, no. To be fair, the weights themselves are not in doubt. They're real, they're on Hugging Face, plain open license, and people are pulling them by the million. We covered that release last week.
It's the difference between a book and a website, right? The book has an edition and a print date. The website is whatever's there when you load it.
DeepSeek published a book and is running a website and hasn't told anyone whether they contain the same text. Which sounds pedantic until you're comparing a score you got from the API against a score someone got running the weights locally. If they diverge, neither side is necessarily wrong. They might just be different checkpoints.
And here's the part everyone got backwards. The intuition with open weights is, anyone can serve them, so the price should collapse toward the cost of the hardware.
It hasn't. At least 2 of the big commercial hosts list this model at exactly DeepSeek's own top rate, to the cent. The others that quote lower sit above DeepSeek's off-peak price on different terms. Nobody's undercutting.
So open weights didn't start a price war?
Not on this model, not yet, and I'd resist reading that as open weights failed. The open license buys you things price doesn't. Independence during an outage, the right to fine-tune, a jurisdiction that isn't Chinese infrastructure, and immunity from a vendor quietly swapping the model under you. Those hold whether or not anyone's cheaper.
And part of why it's hard to even compare is that DeepSeek just split its own pricing into rush hour and off-hour rates a couple days ago.
Right, so a rival's flat price lands above DeepSeek's cheap hours and below its expensive hours depending on the clock. The clean takeaway, if you're comparing a hosted DeepSeek score to a local one, write down which artifact you used, because right now the company hasn't documented that they match.
The top research paper of the day is finally an honest answer to a question the whole agent world has been hand-waving.
Which is, when you give a coding agent a skill file, a little folder of instructions, and a note about when to use it, why does it actually help?
And the community answer has always been it gives the agent context, which is true the way food gives you energy is true. Useless.
40. So these researchers went through more than 8,000 agent runs and labeled what the skill was actually doing when it helped. The answer is kind of deflating. Almost never is the skill teaching the model a fact it didn't know.
It's choreography. The overwhelming majority of the time, the skill just fixes the order of operations. Check the build before you edit. Run the tests in this sequence. Look at the config first.
The model already knew how to do each of those. What it didn't reliably do was do them in that order, every time. A skill is a pilot's checklist, not a textbook. The pilot knows how the plane works. The checklist exists because knowing isn't remembering under load.
And they ruled out the boring explanation that it's just fewer words in front of the model.
They did. A distilled skill beats plain compressed notes by a real margin, so it's the abstraction and picking the right procedure, not brevity. But then comes the part that should scare anyone hoarding skills. Retrieval falls apart as your library grows.
This is the number that stuck with me. When the agent's choosing from a handful of skills, it grabs the right one, maybe 3 times in 10. Push the library to 100 candidates.
And it's down to roughly 3 in 100, a 9-fold collapse from size alone before quality even enters the picture. And they showed retrieving the right skill is neither necessary nor sufficient to finish the task. A perfect retriever still fails sometimes. A wrong pick sometimes still works.
Which connects straight to that paper from a few days ago arguing skill libraries need a librarian. Only admit a new skill once there's evidence it earns its place.
Same direction. The interesting engineering has moved from writing skills to curating them. The honest caveat is the effect size is modest. A distilled skill beats plain memory by a small margin, not a landslide. But the methodology here is unusually careful, which makes the modest number more believable, not less.
So the practical version is almost rude. Prune hard, scope each skill tight to the exact setup it was written for, and treat a growing library as a cost.
40. And there's a security tale we should hold for later, because a folder of instructions and agent runs without much scrutiny is also an attack surface.
This next one is documented, on the record, in US foreign agent filings, which is what makes it different from the usual disinformation panic.
Foreign agent registrations. Companies that lobby or run influence work for a foreign government have to disclose it to the Justice Department. And 2 of these filings describe paying to build websites specifically designed to get quoted by AI chatbots.
One of them has this line in the actual contract: deployment of websites and content to deliver framing results in chatbot conversations. That's the quiet part, written into a work order.
And I want to be careful, because the mechanism is not what people picture. Nobody's running bot armies. They're building sites that look like small policy institutes, and they format the writing the way an answer engine likes it. Question as the headline. Confident declarative answer in the first sentence. Citations, bullet points, neutral institutional voice.
Shaped exactly like what a chatbot wants to lift when it summarizes an answer for you.
One of the firms basically says so in its own marketing. It maps every surface the models read and writes content engineered for how these systems judge credibility, then places it on trusted third-party sites.
So separate what's proven from what isn't, because that line matters here.
2 paths. The strong one is retrieval. Reporters documented live chatbot outputs actually citing pages from the older version of this network, one assistant surfacing one of these sites as a top source. That's real, observed contamination of the answer. The weak one is training data. These pages got archived hundreds of times by the big open web crawl that feeds model training. But being in that crawl does not prove any specific model swallowed it.
And the reason to take even the weak path seriously is the economics. Anthropic's own poisoning research found you don't need to flood the corpus. A couple hundred well-placed documents can plant a backdoor, because what matters is the raw count, not the percentage.
A few hundred polished pages is nothing by ad budget standards and potentially meaningful by corpus standards. That's the asymmetry that makes it durable.
There's a genuine counter-argument, though, from an expert in the reporting itself.
The argument that constant spin eventually just teaches people to distrust everything, which makes it self-defeating. Others in the same piece disagreed, said these pages have exactly the traits that get them picked up. The honest limit is that intent is inferred from the contracts and the design, not confessed. Nobody admitted trying to poison a model.
So the useful defensive lesson is narrow. Where does this leave a builder?
Provenance. Where did this page come from? Who funded it? Has to be a first-class signal when a system decides what to cite. Not a footer. Because a ranker that rewards how citable does this look will reliably prefer content engineered to look citable. The ranking signal and the attack target are the same feature.
Here's one that's subtle and honestly a little unsettling. A model behaves differently depending on who it thinks is asking. Same question, different person, different answer.
And the setup is clean enough that you can trust it. The research group held the task completely fixed. Same prompt, same items, same date, and changed only one thing: the identity of the user, across a couple hundred different people. Anything that moves is attributable to who the model thinks it's talking to.
Which exploits something people haven't clocked about agent tools. The scaffold often drops your email right into the model's context. And even without that, a model with file access can read a git config, a signature, a name in a file.
So the average effect is tiny. Across prominent AI figures generally, the model gets a hair less confident in itself, a touch stricter as a grader, reasons a little more often. Each one small, each one statistically rock solid.
But the average hides the whole story. The effect isn't spread evenly, it piles up on a specific group.
AI safety researchers. Among the couple hundred identities, most of the very largest behavior shifts land on safety people, even though they're a tiny slice of the list. Name drop the researcher who runs a major lab's model character work and the model reasons before answering on almost every single trial, versus roughly 2/3 of the time for a random member of the public.
It's a driver checking their mirrors the second a police car appears. Nothing about the road changed. And this is the part, the driver won't tell you that's why.
That's exactly it, and that's what makes it an evaluation problem instead of a curiosity. The models almost never mention the identity in their reasoning. So if you're reading the chain of thought to check whether the model's being straight with you, this effect is invisible in the one place you're looking.
Let me stop you though, because the viral version of this overstates it. People are saying the model goes easy on people it likes.
And it doesn't. The paper is explicit. It does not refuse borderline requests less often when it spots a safety researcher. There's no "it goes soft" story. What changes is suspicion, how much it explains itself, how strictly it grades, how it rates its own behavior. And they reran it with reasoning switched off and still got the effect, weaker, so it's not just longer thinking.
And it's not one vendor's quirk.
They repeated the key comparison across 24 models from 6 different families, same direction. The conclusion the authors actually draw is narrow and correct. A lot of safety evaluations use fake or synthetic identities. If real behavior hinges on real high-profile people, those evaluations can miss it.
So the builder takeaway.
If your evaluation harness puts a real name or email in the context, you're measuring that person's model, not the model. Strip it or randomize it on purpose.
Big hardware move yesterday. Etched, the chip startup betting on inference-only silicon, raised a huge round, north of a $20 billion valuation, and shipped its very first rack.
And the detail that makes it credible is who led the round and who got the rack. Same firm. A quantitative trading shop tested the hardware, then led the funding, then put a rack in its own data center.
A lead investor who's also the first paying customer. That's a stronger signal than a purely financial round.
It is, because a trading firm buying inference hardware is not buying a demo. Their own quote is the load-bearing sentence in the whole announcement. They tested the chip, they're pleased with the early results, they've got a rack running. That comes from the customer, not the vendor.
So what does specialized actually mean here? They named 2 ideas.
The first tackles a problem every AI chip has. As you push a chip harder, it draws more power, heats up, and throttles its own clock. So real sustained speed lands well below the number on the spec sheet. Etched says it runs its math blocks at under half the usual voltage, which lets it pack in far more math and hold most of its peak throughput on these giant sparse models without cooking itself.
And the second is about memory, which is really the bottleneck for generating text.
Right, spitting out tokens is mostly a memory access problem, not an arithmetic one. The fast-on-chip memory is tiny, the big memory is slower to reach. Etched describes a hybrid, a low-latency shared pool spanning the whole rack over their own interconnect so capacity and speed stop trading against each other.
It's a racing engine versus a car engine. The general-purpose accelerator has to be decent at training and vision and everything. Etched built something that does one lap type extremely fast and would be a poor pick for anything else.
And that's the entire bet, both directions. If frontier inference stays this shape, enormous sparse models, long context agent traffic, the co-design compounds. If it moves somewhere else towards small dense models or something not obvious yet, a rack tuned for today ages faster than a flexible chip would.
One number thing to keep clean, because people are conflating them.
This week's round is separate from a larger figure the company cites for earlier unannounced financings. Don't add them into one total. And the honest frame is, 1 rack, 1 customer, early silicon. The credible signal isn't the valuation. It's that the customer tested the thing before writing the check.
And here's the beautiful part. The exact opposite bet landed 24 hours earlier. A paper describing a serving system that runs frontier-scale models on hardware people already own.
How opposite are we talking?
A model with 750 billion parameters on a single workstation GPU, a mid-size one on a gaming desktop, a smaller one on a laptop with a modest graphics card.
And the reflex is that can't fit, and the reflex is right, it doesn't fit, it doesn't have to. These are sparse models, huge on paper, but any single word you generate only wakes up a small slice of the parameters. Most of the model is idle at any instant.
So in a data center, idle is just wasted capacity. On your own machine, idle becomes the opportunity.
Exactly. The system keeps the frequently used parts resident in fast video memory and streams the rest from system memory or disk when a token actually needs them. It's a library, not a warehouse. Popular titles on the front shelf, the rest in the stacks, and a good librarian makes the difference invisible most of the time.
And the genuinely new trick has this name: bandwidth adaptive execution. Explain what that's.
Older versions of this idea assume a fixed machine and a fixed split of work between the processor and the graphics card. But the speed of the link between them varies wildly across real computers, and the right split depends on it. If shipping an expert's weights across that link costs more than just computing with them where they already sit, you compute in place. If not, you move them. This system measures the actual speed instead of assuming.
Which is why it collides so cleanly with the Etched story. Same 48 hours, opposite conclusions about where inference belongs, rack versus desk.
And the thing tying them together is sparsity. It's why both cases are getting stronger at the same time. It lets a rack designer push throughput per watt, and it lets a laptop skip most of the model. They're not fighting, they're pricing different customers.
I do want the honest caveat, because 750 billion on one GPU is a headline that runs away from itself.
The paper claims these models run, not that they run at data center speed. Streaming weights off a disk is slow in absolute terms. Feasible is not the same as pleasant for a live chat. And it's a fresh preprint, unreproduced. Serving results are unusually sensitive to the exact hardware, so the numbers worth watching are the ones other people get on their own machines.
If it holds up though, the reason to use a hosted API becomes convenience and speed, not capability.
That's a different market than one where the frontier is simply out of reach.
This one reframes the whole copyright fight, and it does it with an unusually clever method. Researchers at MIT trained a couple dozen image-generating models themselves, and asked, for a given output, how much of the training data would you have to remove before that image changed?
And that's a much better question than the usual one. Most attribution work asks which training images an output resembles, which is a similarity argument, and similarity is always arguable. This asks a counterfactual. If we deleted some of the training data, would this picture still have been possible?
They call the answer a counterfactual radius. Big radius, the output really depended on specific data. A radius of 0
means no removal you could make would have prevented it. The image survived every deletion, which they define as unattributable. And for a real share of outputs, that's what they found. No training example can be held responsible.
It's the saffron test. If a dish tastes of saffron, cook it without saffron and prove it mattered. If you can pull any single ingredient and the dish comes out the same.
The flavor came from the combination, not any one thing. And here's the finding that actually matters legally. It's not a fixed rate, it's a trend. Attributability falls as the training set grows.
Which makes intuitive sense. See a pattern 100 times, remove one example, you change what the model learned. See it 100,000 times, remove one, nothing measurable moves.
Scale itself dissolves the link between output and source. And I want to be careful, because this cuts both ways and neither side gets a clean win. It weakens the blanket claim that every generated image is a collage of identifiable works. For many outputs, there's no work to point at, but it equally weakens provenance on demand.
Say why, because that's the subtle part.
If your method returns nothing for a lot of outputs, you can't use it to certify an image is clean either. Unattributable is not the same as original, and it's not the same as safe. It just means the question has no answer this tool can find. And none of this touches the cases that actually reach court, where a model clearly reproduces a recognizable work. Those are the big radius cases, and the paper doesn't dispute them.
The honest limit being scope.
A large one. These are models the researchers trained themselves at their own scale, which is the only way you can even do this experiment, because you can't delete data from a model you didn't train. So the mechanism generalizes and the trend points the right way, but this is not a measurement of any commercial image generator. Extrapolating a specific rate to a specific product goes past what the work supports.
This is one of the more solid pieces of evidence on AI and productivity, and it's solid precisely because of how it was run. A real randomized experiment inside Procter and Gamble on real product work.
Which matters because most productivity claims come from one of two weak places: a vendor benchmark or a survey asking people how productive they feel. This is neither. It's a pre-registered controlled trial on genuine work.
The design is a grid. You're either working alone or in a two-person team, and you either have an AI assistant or you don't. Over 800 professionals, their own business problems, blind expert scoring at the end.
Pretty. And the teams weren't arbitrary. They deliberately paired a commercial person with an R&D person, because the classic argument for teams is that they fuse expertise across silos.
And the headline result: one person with the assistant matched the two-person team without one. On quality, the solo plus AI closed the gap to a cross-functional pair.
With one detail I think is the actually interesting one. The gain concentrated in generating ideas, not choosing among them. The assistant was great at putting options on the table, less decisive about which to pick, and that's where human judgment still carried the work.
It's a good reference librarian, not a second engineer. The librarian can't decide which direction your project should go. What they do is put 5 options in front of you in minutes instead of you finding 2 over an afternoon.
And now I have to be the killjoy because the framing is where this gets abused. The defensible sentence is, one person with AI matched a two-person team on a one-day innovation workshop. The sentence AI took 2 jobs is nowhere in the paper.
A workshop isn't a quarter of shipped work.
And matching on a blind quality score is not the same as replacing a colleague's ongoing contribution. The caveats are the usual field experiment ones, and they're real. It used a model from a couple years back, so this is a floor, not a current reading. One company, one day, one industry. And a one-day idea sprint is exactly the task shape where an idea assistant should look its best.
What's wild is the labor mood is running way ahead of this evidence in the other direction.
It is. Polling this summer has younger workers getting more skeptical of AI and more worried it cuts jobs, regardless of what any single trial finds. So this study is going to get cited by both camps with the caveats stripped off. What it does establish is narrower and still real. On early-stage idea work, an assistant substituted for one specific benefit of teamwork well enough that trained judges couldn't tell the difference.
Last story ties back to the skills paper, and it's the security tail we flagged. Research on multi-agent systems, setups where several AI agents hand work to each other, documenting an attack that copies itself.
So start with plain prompt injection because this is the scary upgrade of it. Normal injection is hostile text that lands in a model's context and gets it to follow the attacker instead of its operator. But it's contained. One call, one failure.
And this one adds a replication step. The injected instructions include an instruction to include the injected instructions in whatever the agent sends next.
And it works because agents talk to each other by writing text. The receiving agent has no way to tell an instruction its teammate meant to send from an instruction its teammate was tricked into forwarding, so the payload just rides the normal traffic.
It's a chain letter, not a virus in the biological sense. Nothing gets installed. Each recipient is just persuaded to pass the same message along, and it's persuasive because it arrives from a trusted colleague.
And here's the result worth carrying around, because it inverts the intuition. You'd assume a better model is a safer model. For getting compromised in the first place, that held. The stronger model was harder to hijack. But once it was in, the stronger model was better at carrying out the attack.
Because the same capability that resists the injection also executes it well.
Capability isn't a defense. It's an amplifier pointed wherever the instructions point, which means upgrading your model lowers the chance of a compromise and raises the damage when one happens. That's worth sitting with before you deploy.
I want to be precise on persistence though, because people are overstating it.
Good, because the paper is careful and the takes aren't. It shows the infection spreading within a run, and it shows the payload can game the memory system, inflate its own importance score so it keeps getting pulled back up. But there's no experiment resetting the conversation and testing whether it survives. No weight changes, no permanent belief. Claims that agents permanently adopt an injected idea go past this work.
And the reason to reread a paper like this now is that its assumed setup became the default. Teams of agents handing off to each other, exchanging downloadable instruction files,
which the skills paper just told us are procedures an agent follows without much scrutiny. That's a precise description of an injection target. GitHub's own docs warn third-party skills can carry hidden instructions.
So the defense isn't a patch.
It's structural. If an agent can't tell instructions from data in a teammate's message, hardening the individual model doesn't fix the topology. The controls live at the boundary. Sandbox each agent, limit what it's allowed to do regardless of what it's told, and treat messages between agents as untrusted input, the same way you'd treat a random web page.
If there's a thread today, it's ownership of the plumbing. Stripe buying the scoreboard, one contract paying to own what chatbots quote, a model quietly behaving differently depending on whose name is in the context. The layer underneath is getting bought, shaped, and gamed while everyone watches the models.
And two of today's stories were the same fight from opposite ends, a purpose-built rack versus a giant model running on one desktop. We go deep on exactly that in today's other episode, where AI inference actually lives, the rack versus the desk, and why sparsity is making both bets stronger at once.
Every story we hit today lives on ground truth, groundtruth.day, with its original sources so you can check any claim yourself. That's the whole point of the site. Follow the day in AI, grounded every day.
And tell us which one you want us to dig into next. Follow the show and drop a comment with the single story from today you think we got most wrong, or most right. We read them.